For today's video, I'm going to teach you how to answer the question shown here. I invite you to pause the video right now and try this question on your own first, then hit play and I'll show you how to do it. Using principles I've discussed elsewhere, linked to in the description below, we need to have the equation. Now, the equation is not given in this problem, so what do? Well, we're going to read the question and see if we can extract equation information from it. It begins by talking about how much mass of aluminum is produced. Well, that must mean that aluminum is the product in the chemical reaction. So I write it down on the right-hand side of the arrow. Now, anytime you're doing one of these kinds of questions with electrolysis, some metal produced is going to be that metal in uncharged form. No charge written over here because we're doing an electrolysis from a compound that contains metal atoms with a charge, and it's eventually going to plate out that metal with zero charge. Aluminum, calcium, sodium, titanium, whatever it is. Now, it also talks about aluminum chloride being thrown into the mix. Where do I throw that? Yeah, it must be on the reactant side right there. And as you should note, aluminum, as indicated in this table, always has a +3 charge in any compound. And that holds true for aluminum chloride here. The next step is we need to convert the amps provided in the question to coulombs. How do we do that? Well, it turns out amps times seconds equals coulombs. Now, the question, of course, gives us an amount of time that this amperage is run in hours. So I need to do some conversion, hours to seconds, as indicated right here. You'll notice that my hours cancel out hours here, minutes, minutes, and I multiply all this thing through with my 12.5 amps, and I end up getting final units of amps times seconds. And what is amps times seconds? Yeah, as I just pointed out, that is the same thing as coulombs, abbreviated by the letter C, not to be confused with the element carbon. Different stuff, okay? Now what do? Well, that takes me to the next step. I'm going to use Faraday's constant, which is this number right here, and has units of moles of electron per that number of coulombs. I do that in order to figure out how many moles of electrons this number of coulombs comes to. This number divided by 96,500 coulombs, that is Faraday's constant, equal to 1 mole of electrons, ends up coming to that many moles of electrons is what you're going to get if you pass this amperage through this system for 24 hours. That takes me to the next step. I'm going to use the Bounce chemical equation to take my 11.19 moles of electrons and eventually convert to grams of aluminum. How do I do that? Well, over here, as I just pointed out, aluminum is always going to have a +3 charge. So for the sake of just simplifying this, I'm going to remove the chlorine and write out aluminum's +3 charge there. Now, if I have aluminum +3 right here, and it's going to get reduced down to aluminum 0, how many moles of electrons is that going to require? Yeah, it's going to require 3 molar equivalents of electrons. That is my stoichiometry there that will allow me to make this leap. I do that typical dimensional analysis way by laying down set parentheses with my units. Moles of electrons here cancel out moles of electrons here. Moles of aluminum cancel out moles of aluminum right there. And I can relate these two to each other because moles of one thing, moles of another thing can touch. But what numbers do I use? Well, as you can see, I've got an implied coefficient here of 1 next to the moles of aluminum. How many moles of electrons do I have to have? Yeah, it's got to be 3 because that's how many molar equivalents it takes to reduce aluminum +3 down to aluminum 0. You'll notice that my moles of electrons cancel each other out. Now, what do I put here? Well, that's the atomic mass of aluminum, which you can see on the periodic table is around 27 grams per mole. You'll notice the moles of aluminum cancel each other out, and I'm left with a final answer in units of grams. Multiply this stuff all through, you get a final answer of 100.71 grams, which is option B.